So for this section, or for this portion of the videos, we are going to be talking about how to express exponential models. So things that are given to us in this a, b to the x format, and putting them into something that looks very much like our exponential growth and decay. So the format is that if I have a, b to the x, I can rewrite that as a e to the natural log of bx. Now, again, they're utilizing the idea of e and natural log do cancel each other out. But if we notice, this looks an awful lot like a equals a naught e to the kt, where k is that natural log of b part and the t is in place of the x. Now, the reason that we want to use this type of thing is because we're able to compare things like population growth. And this can show growth as a percentage based on one individual population instead of a general number. So for example, if I had two countries, let's say China and Luxembourg, okay? So 1 million people is not the same in those two countries, okay? A million as far as population amount. If we saw an increase of 1 million people in China, that may be a very, very small percentage, okay? But in Luxembourg, it would probably be a larger percentage. So instead of us trying to compare what 1 million people and 1 million people looks like, we are going to look at setting these up so that we have how a country or how a population is growing comparatively to itself. Okay, so before we get into one about countries, let's talk about just one in general. Okay, so they ask us to rewrite this in terms of base e, and they want us to express it with the natural log and then actually process it out. So we have 4 parentheses 7.8 to the x. Okay. So we have this. Now, format was, so this is our a, b to the x format. And we said that this goes to a, e, natural log b, x. So that would look like 4 e natural log 7.8 x. So this would be our format in the natural log format. Now, if we actually evaluate natural log 7.8 so that we have it, and at 3 decimal places, we're going to get 2.054x. Okay, so this is what it is in the natural log, and then this is what it is in the exponential, or excuse me, in the decimal form written at 3 decimal places. Okay, so now let's take a look at one more example. Okay, and so here we have populations for India, Iraq, Japan, and Russia. Okay, and so we have each one again written in their a, b to the x format. And I'm just getting these transferred for us. Now, notice each one has a different starting amount, but I don't really know how something is growing comparatively to itself with the way that these are set up. Now, I could probably take a gander as to which ones are growing or decaying based on my base, but again, I don't know kind of how quickly or how slowly or anything of that nature. So we would ideally like to be able to say that such and such country is growing faster or slower than another country, or if the ones that are growing, which one's growing faster, etc. So here I've got our India, Iraq, Japan, and Russia. So if I take India, and I'm just going to show the setup for this first one, and then I'll have the rest of these. This is going to go to e natural log 1.008 t. Okay, so that's going to be the format that we do. And so that is going to come out to be 1173.1 e 0.00797 t. There, I realize my numbers are getting kind of smaller. Let me break that down just a little bit. So we get 1173.1 e 0.00797 T. Okay, is what we got for that one. So it was India. So now we've got Iraq. Okay, and so that was 31.5. And again, if we reset this, E natural log 1.019 T, we get that is 31.5. E 0.01882 T. Okay, now because this is positive, I know that this is growing. This one's also positive, so I know that it's growing. Now, because Iraq's number is bigger than India's number, I know that Iraq is growing faster than India. Okay, so now Japan, I'm going to have 127.3 E natural log 0.994 T, which is going to be 127.3 E negative 0.00602 T. Because that is negative, we know that that is decay or that it's shrinking. And then we've got Russia, and that's going to be 141.9 E natural log 0.995 T, which is going to be 141.9 E negative 0.00501 T. Again, because that's negative, we know that it is decay. The other thing that we know is because this is more negative, okay, it's 0.006 versus 0.005, Japan is losing population quicker than Russia is.